This is the Almost Timely newsletter for the week of August 27th, 2023. Content authenticity statement: 100% of this newsletter was generated by me, the human. No AI was used to generate the content of this issue. Reminder, that's really important because when you disclose what is and is not AI, you are reasserting your copyright claims over the things that are not AI. What's on my mind this week? A deep dive into fine-tuning large language models. Let's talk about tuning and customizing large language models in generative AI, because I've had quite a few calls this past week about this topic, about how do we customize language models for your business using your data. We'll talk about it in general and then talk about some of the options that are available. Before we begin, let's establish one key fact. There is no non-technical way presently, as of the time of recording, no non-technical way to fine-tune a model. I'm sure there are plenty of vendors that would love to tell you that, like, they have a non-technical, flexible, scalable, turnkey system that's integrated and all this stuff, reassuringly expensive, that makes it easy to snap your fingers and boom, you've got a fine-tuned model. But no. The reality is the process from beginning to end is inherently technical in nature. The process of fine-tuning a model, it is technical, right? Now, it's gotten much easier in the last few years, but it is by no means as easy as, like, editing a Spotify playlist. Let me put it in cooking terms. First, what is fine-tuning a model? Fine-tuning a model is basically customizing a large language model with your data. It's like modifying a previously cooked dish to better suit your needs. Let's say you ordered a pepperoni pizza, but you got a sausage pizza, right? You have to figure out a way to remove the sausage and add pepperoni. That is what fine-tuning is. There is no way to do so that does not involve cooking in some capacity, right? If you get the wrong pizza and you're going to change it around, you have to do some cooking. Now, some tasks, like adding more salt, right? That doesn't require a whole lot of cooking, but you're still cooking in some capacity when you're modifying a cooked dish. The same is true for fine-tuning. We're going to use a lot of cooking analogies throughout to explain this process. Now, there is a reason why there is no non-technical way to fine-tune a model, and the reason's pretty straightforward. When you're fine-tuning a model, you are customizing it based on your data, and your data is inherently unique. There are all kinds of gotchas in your data that are not shared by other companies, and it's very difficult then to establish sort of a one-size-fits-all or even a one-size-fits-most process for fine-tuning. Think about something like HubSpot, right? Maybe two companies have a HubSpot instance each, right? You've still done customizations. You have custom fields, you have custom this, that, and the other thing. And so there's no one way to say, okay, we'll just take the standard HubSpot fields and we'll use that to train a model. No, that's not going to work out very well for you because of all those customizations, because of the way that even you used certain data like UTM tracking codes. All that's going to be different from company to company. So you can't build one size fits all, which means you can't build a turnkey non-technical way to do it. Now, why would you want to fine-tune a model? The short answer is that you want a large language model that knows about you specifically, your data, your information, your customers, etc. The use cases for such a model are fairly obvious, right? You want something that delivers results that are very specific to you. Asking ChatGPT about your company, depending on its size and public footprint, can be a very unsatisfying experience, right? Asking a tuned model about your company should deliver the results you want because it's your data. You're telling it what to do. The applications of fine-tuned models are also fairly obvious. If you're building a customer chatbot, for example, you would want it to discuss topics that your customers are specifically asking about. You would want that chatbot to have domain knowledge at a level of depth that a public model might not have, or perhaps perspectives derived from your proprietary data that public models simply wouldn't have because they don't have access to your data. They shouldn't have access to your data. So the first thing we have to think through is, what is the intended outcome of our fine-tuning process? Because that will determine the technical approach you take. The key question to ask is whether or not your large language model implementation needs what's called perfect memory or not. Here's what we mean. There are use cases where you want the model itself to know all the information about a domain of expertise, where you want it to be expert in that domain. In a cooking analogy, You'd want a model to be able to generate a pepperoni pizza of every kind, right? At any given time, it should have full, complete knowledge of pepperoni pizza without the need to bring in any additional help or any additional data. It's the perfect pepperoni pizza baking machine. That's what perfect memory is. If you are, say, an accounting company, you would want that model to have perfect memory of every accounting regulation and what GAAP is and all these things without needing to rely on any outside data. It should just be an accounting whiz. And so you would want to tune a model to have perfect memory of the world of accounting. Now, you don't care if it knows or doesn't know Johnny Cash lyrics, right? You care that it knows every possible piece of accounting information inside it. That's perfect memory. There are other use cases where the model just needs to be able to generate language intelligently, but it's going to be deriving its source of truth, its facts, from other data sources. It's essentially a language interpretation system. That's what I would call it. This is how Microsoft has done its implementation of GPT-4 with the Bing search engine. When you ask Bing questions through the Bing chatbot there, it's not asking GPT-4 for the knowledge. It's not asking GPT-4 for facts. What it's asking the model to do, and you can see it when it's in operation, is translate our conversations, the questions that we have, into formatted search queries that work best for Bing. Then it retrieves those results from the Bing search engine and puts it back into GPT-4, puts all the results into GPT-4 to synthesize a conversational response. At no point, though, is it saying, hey, language model, tell me whether this thing is true or not. And that's why Bing and Bard are particularly good at answering questions that require fresh data, because they're not using themselves as a source of knowledge. They're just using themselves as an interface to a different data system. So why would you choose one or the other, right? Why would you choose perfect memory versus language interpretation? A perfect memory system is self-contained, right? You have the model that you've tuned and the interface to the model, some kind of web interface probably, and that's it. It doesn't need much infrastructure beyond that. This situation is good for answering questions that are, say, conceptual in nature and for facts that are firmly fixed. Let's say, you're an insurance company and you train a foundation model on all the questions and answers that customers normally ask about your policies. Like, how does this annuity work? What's the best choice for this? How does this, term in this policy work? A perfect memory model would be able to answer those questions. That's a great use case for a perfect memory model because the data doesn't necessarily have to be fresh, right? Your policies probably don't change day to day. I would imagine from a regulatory perspective, your policies probably aren't allowed to change a whole lot. Think about like in accounting and taxes. A company like H&R Block would not need to have a model stay up to date on the very latest in tax information. It just has to be tuned up once a year with whatever's new in tax law at that time. Now, it's, again, a good use case for a perfect memory model. A language interpretation system is useful for when you have a lot of data flowing into a system that's rapidly changing, right? This is a kind of model that needs a lot more infrastructure around it, but the data is fresh, and the foundation model doesn't need much training at all to be able to succeed in its tasks because it's not being asked to generate the truth. It's just being asked to pass data back and forth from a system and turn the inputs and outputs into natural language. A good example of this would be a system that answered questions about stock prices or the weather or any fast-changing data. You can't tune a model fast enough day to day to keep up with that data. You're better off having it be a language interpretation system where the model just generates the language and there's underlying data systems. Now, there are advantages and disadvantages to each of these approaches. Perfect memory models have a very high compute cost up front, right? It takes a lot of hardware, a lot of resources, a lot of computational power, a lot of electricity to tune a model. But then once you're done, you have lower compute costs in operation because the model isn't changing at that point. You're just handing off this fixed piece of software and it just does its thing. Perfect memory models take longer to get up and running, and the information in them can get stale pretty quickly. Now, again, for stuff that doesn't change a whole lot, that's perfectly okay. You would not use it for the weather. Language interpretation systems have lower compute costs up front because you're not changing the foundation model very much, but they have much higher compute costs in the long run because they require a lot more horsepower to connect and process that data. You have a big infrastructure footprint, this database, this architecture around it, the stuff that the model can interface with. There, you have to have all the support systems in place. So the operational cost of a system like a language interpretation system is higher because you are You have more systems to run, and you're always constantly bringing in new data, right? When the stock market closes, boom, you have more stock data to have in this specific kind of database. So once you have a general idea of what kind of model and system you're going to need, the next step is to start laying out your system architecture, right? One of the biggest mistakes I see vendors make in this space is not having any kind of abstraction layer in their software. What is an abstraction layer? It's a layer of technology that you create so that the underlying model is insulated from the rest of your infrastructure. What does that mean? Basically means if AI systems were cars, you'd want the car designed in such a way that you could pull out the engine and put a new engine in without having to rebuild the whole rest of the car. Right? That's what an abstraction layer is. It makes it super easy to pull the engine out, put a different engine in. With AI systems, you want an abstraction layer so that the underlying model can be swapped out, because language models are evolving so fast, so quickly, that if you tie yourself to one specific model, that creates a lot of risk. Creates a risk that the model you build on is going to become outdated as soon as the next big thing comes out. Right? I was at the Macon conference about a month ago now in Cleveland, and I talked to some of the vendors and talked about, asked them about the back end architecture and stuff. And after the beer was being served, and folks were like, "Yeah, we built on GPT-3." I'm like, that's a 3-year-old model that is nowhere near best in class anymore on many of these tasks. But they had spent so much time and effort building right into the model instead of creating an abstraction layer that they physically cannot pick up GPT-3 and put GPT-4 in. Can't do it, right? And so they're stuck, and their products are stuck. And that means that they've aged out really quickly and can't keep up with more agile competitors, right? So you need to have that abstraction layer as part of your strategy for how you deploy these things. Now, after you've figured out your system architecture, you now have to tackle what is the most difficult, most time-consuming, most challenging, and most arduous part of fine-tuning a language model: your data. See, you can't just gather up piles of random documents from your company and put them in a model any more than you can just take big piles of random ingredients, drop them in a stand mixer, and hope you end up with a pizza dough. That is literally a recipe for failure. The same is true for language model tuning. With perfect memory systems, you have to build data sets, big data sets, in a compatible fine-tuning format. And there's a number of different standards for that to tune the model with. Right? An example of what that would look like or sound like is it's a series of prompts and responses. Right? Prompt: what are the names of the Trust Insights founders? Response: Katie Robert and Christopher Penn. Prompt: what year was Trust Insights founded? Response: 2017. Prompt: what is the Trust Insights website domain? Response: trustinsights.ai. That's the kind of data you would need. You can see it's basically questions and answers, at least for a basic training set for a chat-style model. Now, consider how much data you have in your company that you'd want to train a model on, that you want to tune it on, and the effort it's going to take to create the training data set, right? Not just having the data, but creating it in this format. You can understand why this is a huge task, a Herculean task, and why it takes so long to build a fine-tuning data set, right? This is where you're going to spend your time. Even if you're using a language interpretation system, you still need to take that same training data and format it for the underlying database that powers these systems, right? There's specialized databases called vector databases. They have their own data formats, which necessitate converting your data, and they are completely incompatible with all your existing databases. Totally. You have to translate all your data into their format so that a large language model can interface with them. You can't just plug in your existing data. It's a big task. Suppose you have all that. Suppose you've done all the heavy lifting. Now we can start to talk about the fine-tuning process. And there's a variety of different ways to do that. A full tune is where you take your data and re-weight the entire foundation model with it, right? This is like ordering a pizza. It's the wrong flavor. It has the wrong toppings, right? You go back in the kitchen with the right ingredients, and you essentially make a new pizza from scratch, right? You take the old one, chop it up, and glue it back together, and you've got a new pizza that has the correct ingredients. That process isn't used much today for model tuning because it's so computationally intensive. Though people actually do use it for model merges, which is a topic for a whole other time. There are advanced fine-tuning methods, one called low-rank adapters, or LoRa, which adds a layer of new model weights on top of a foundation model. So think about LoRa. Think about like ordering at pizza, right? You order the pizza, it's got the wrong toppings. You're like, oh, great, I ordered pepperoni at sausage. Instead of sending the pizza back into the kitchen or chopping up and rebuilding it from scratch, you just get out a fork. Get out a fork, you scrape the toppings off that you don't want, along with the cheese. You put the toppings you do want on there, put some more cheese on there, pop it in the oven for a couple of minutes, and boom, you've got a new pizza, right? You've kept the majority of the pizza the same, right? The dough and all the stuff is still the same. It's the same pizza, but you've just changed the toppings. That's effectively what LoRa does with language models. It lets you replace some of the data in the model with a new layer of model weights on top of it that force the model to behave the way you want it to do. So that's the fine-tuning process for perfect memory models. For language interpretation systems, you will need that specialized vector database. There's Weaviate, Chrome, Pinecone, a bunch of other ones. You have to convert your data into those data embedding formats, and then you connect your database through a utility system like LangChain, which is like a scripting language that glues together all these different components, so that your language model can converse with your data. It can go send inquiries into the database in its own peculiar format, pull out the embeddings, and then lets you converse with it. As I said at the beginning of this note, there is no way today to do this process that is non-technical in nature. Every approach has varying levels of technical skill and complexity that's required, along with a fair amount of infrastructure. Despite all the techno-babble about implementation, the hardest part really is the gathering and formatting of data that you want to use to fine-tune a model, because most of the time, let's face it, the data in our organizations is just a hot mess, right? Without the necessary ingredients, the data, the technical parts in fine-tuning just don't matter. So that's fine-tuning in a nutshell. There's a lot more technical detail we could go into that isn't worth it right now, but it's a lot, and it's very, very technical. But if you want a language model to do your bidding, if you want a language model to be able to answer questions about your business that are specific to your business, that's what you use fine-tuning for. All right, let's take a look at what else is happening in the news. This past week, did the quarterly bake-off of 5 large language models on the Trust Insights live stream. We looked at Claude 2, ChatGPT with the GPT-4 model, Microsoft Bing, Google Bard, and LM Studio using the Mythomax L2 model. The winner, watch the episode. It's not the same winner as the previous quarter, though, so that's worth pointing out. If you have not already done so, watch the keynote I shot at MACON about a month ago now, still mostly current. And if you like that talk and you want to have a version for your company, I do have a thing in the newsletter where you can request how to get that booking set up. Let's check out jobs. This week, EverCommerce is hiring for a bunch of stuff. CES marketing manager, associate director of paid social, product marketing manager, paid media specialist, and then senior data scientist at Apex Solutions. So still some hiring going on, although for marketers it is definitely a little bit slower. And this is something that we talked about recently, I think 2 weeks ago, in the Trust Insights newsletter. There is a slowdown in marketing job hiring. So be aware of that. Marketing job hiring, I believe, is like 50% of where it used to be pre-pandemic, and it's down pretty far. So if you are on the job market and it feels like it's a slog, you're not alone and you're not imagining it. There's a recession happening in marketing jobs specifically. In other news, the fight versus Twitter and Threads continues. I refuse to call it X, but it is becoming an even hotter mess over there. This week, the management announced they're removing the ability for you to block people. I'm like, oh yeah, that's going to work out well for them. I don't know who makes the choices over there, but they're not very good ones. We have AI and predictive analytics for enhancing podcast strategy, internal links for SEO, and for a guide for that, generative AI and digital twins, OpenAI opening up the GPT 3.5 Turbo model for custom tuning. So we just talked about fine tuning. You can do that with OpenAI's system if you like. Just remember that model is still being held by a third party. So you probably should not be putting proprietary data in it, but you can tune it for other things. We have detecting table rows and columns and images using transformers, which is pretty darn cool. Lessons from weather forecasting that improve disease forecasting from IBM. Really cool stuff. And a bunch of tech companies just dumped a whole bunch of money, $235 million, into Hugging Face, the repository where a lot of these AI models are stored. So that's pretty cool. That means that they can keep the lights on a little bit longer. Upcoming events. ISBM in Chicago in September, followed by Content Marketing World in DC in September, Marketing Analytics and Data Science also in DC in September, Content Jam in Chicago in October, Marketing Pros B2B Forum in Boston in October, and then Social Media Marketing World in San Diego in February. So lots of events coming up that I'll be at. The calendar is filling up fast, so if you do want me to speak at your event, now is the time to book it because it's getting really, really busy. That is the newsletter for this week. Thank you for being here, for watching or listening or reading. We had a lot of stuff on fine-tuning. Hopefully you found it helpful and got some benefit from it. Thanks for tuning in. We'll talk to you next time. If you like this video, go ahead and hit that subscribe button.